each and every one of you will tell me what a row is and what a column is. Who is this? So let me start mentioning names. If I mention your name, you tell me what you understand by a row and what you understand by a column. Every answer is correct. No answer is wrong. So let me start. Mr. Anthony Dua, tell us what a row is and what a column is. Go ahead. Unmute yourself and talk. When you finish, you mute yourself. Let's do that fast. Mr. Anthony, go ahead. Dua, please unmute yourself and talk. Mr. Dua. Mr. Dua, can you hear us? Hey. Okay. Mr. Fuseni Abdul, tell us what a row is and what a column is.
Rows are the number of activities that are carried on, or trials or events that are carried on, whilst the columns are the entries for each activity or event. Rows are mostly the horizontal entries. They are horizontal or the x-axis, whilst the column are the vertical or y-axis of a matrix.
Okay, so we said every answer is correct, so you are correct. Next, Auntie Jane, tell us what you understand by a row and a column. We can't hear you. I think her network has an issue. Mr. Asari, Galaxy S9 Plus. Yes, tell us, talk to us. We cannot hear from your end. I could see you are talking, but we cannot hear. I don't know if the rest can hear.
A row is a horizontal line of numbers, goes from left to right. A column is a vertical line of numbers, goes from top to bottom.
Okay. That's fine. Every answer is correct. Next person. Who is there? Who is there? Let me see the names. Auntie Dinah. Auntie Dinah Abaka Watin. What do you understand by a row and a column?
So what I understand by a row is it being horizontal, a straight line, just as the other person said. And then the column is also a vertical line from top to bottom.
Oh, okay. That's fine. Every answer is correct. So correct. Mr. Edem, Kojo Ejeyi.
Okay, so a column is let's say something like a vertical, like from top to down, and you can say it's like a pillar, like it looks like a pillar, like when you are building, and then a row is it's a vertical line of numbers. You can say it's like from side by side. Yeah, that's
the row is. Come again. You said the come again.
The row,
column
the
and
row
the row.
is okay. The row is horizontal with, or you can say it's has numbers that has from like side by side.
Okay.
Comes the line, yes, please.
That's fine. So every answer is correct. Let me hear from one last lady, then we continue. What are the names? What are the ladies I can see here? Auntie Deborah, can you hear us?
Hello there.
Yes. Please go
Arrow
ahead.
is arrow is a horizontal curve and a column is a vertical curve.
Oh, okay. So that's correct. So I think in this class, you all gave the same answer. So it means we are agreeing that the row is a horizontal arrangement, whereas the column is the vertical arrangement. Please, is anybody here who has a different opinion? If you have any different answer, let us know. Any different answer? I can't see any hand up. No hand is up. So it means you all agree to this. So that is fine. It means this class has no problem on rows and columns because the challenge with these rows and columns started from the primary school where the teachers will come and say this row, that row. And so most people tend to follow what the teachers used to say. And so they get confused. But I think with the definitions you have given and the explanations you have given, it shows clearly that you people don't have that problem. So it means we can continue. So we know that the row is a horizontal arrangement, whereas the column is the vertical arrangement. So that is fine. Now that we all understand that, we can now proceed. We can continue. So we've defined a matrix as the rectangular array of numbers, variables, or functions. Each of the numbers or variables in the matrix is called an entry or element. So if you take a matrix, the members you see in the rectangular array, each of them is called an entry or an element. So take notes. One day I can ask you. Then we also have what we call the size. Now, before I talk about the size, let me talk about naming. How do we name a matrix? We identify a matrix by a capital letter. We use capital letters to denote or name matrices. So I'll use capital A to say matrix A. So the name of that matrix is matrix A. If you use a small letter, you are wrong. It should be capital letter. So take note. Then we talk about the size of a matrix. And no, once again, before I talk about the size, let me talk about the arrangements in the matrix. As we have said earlier, we said that these elements in the matrix or in that rectangular array are identified by their row numbers and their column numbers. So each element you find or you see in the matrix is identified by the row in which it is found. That's the row number in which it is found and the column number in which that element can be found. So take note. Now, if we agree to that, then we come to the size of a matrix. The size of a matrix is the same as the dimension of the matrix, and it is the same as the order of the matrix. So if I ask you to tell me, maybe I give you a particular matrix, and I ask you to tell me the size or the order or the dimension of the matrix, you should always look for what? The number of rows and the number of columns. So a matrix with m rows and n columns is denoted by m by n. As you can see, m by n is not m times n. It is m by n. That is the size of a matrix which has m rows and n columns. Always the row number appears first before the column number follows. So take note of that. Take note of that. So for a matrix A, the entry in the nth row and the nth column is denoted by M. It's denoted by what? AMN, which is telling us that this element or entry A is found in the matrix, which is capital A, in the mth row and the nth column. Okay, let me go back and let you understand what I'm saying here. Now look at this matrix A. So you see the way I've named it. Sometimes I may not bring the word. I'll just say A is equal to this rectangle, 1, 2, 3, 4. So 1, 2, 3, 4 are the elements or entries of the matrix A. Okay. Now, if you take this matrix A, tell me how many rows are there and how many columns are there? Who is
Say
talking?
two rows and two.
Good. So we have 2 rows and 2 columns. So first row, second row, so 2 rows, first column, second column, so 2 columns. So this matrix A has 2 rows and 2 columns. And so it is what? A 2 by 2. So if I ask you to tell me the dimension, or I ask you to tell me the size, or I ask you to tell me the order of this matrix A, you say the matrix A is a 2 by 2 matrix. That is the size or dimension or order of the matrix A. So you always count the number of rows first, and then you come and count the number of columns. And so you mention the number of rows first by the number of columns. That gives you the size or the dimension or the order of the matrix. I hope that is clear. If you have any question, you just ask quickly and we continue. Now, I can also give you, I have decided to maybe give you some objectives. Maybe if I'll give you objective, then maybe it will be maybe about 30 objectives or maybe 40 objectives. Then I'll give you one full question, a subjective question to answer for 20 marks. So if I give you 40 objectives, that will be 1 for 1 mark. That will be 40. And I give you maybe 2 or 3 optional questions. You choose one for 20 marks so that the marking too will be easy. It will not be difficult for me too much. And so all these are things I can just put in the objectives and ask you questions on. So I can give you a metric like this: A is equal to 1, 2, 3, 4. And I'll tell you to identify the element A11. If I ask you to identify the element A11, as you can see here, A11, the first number is telling you the row number, followed by the second number, which is telling you the column number. Now, if I ask you to give me the element A11, it means I'm referring to the element which can be found in the first row, second column. So element found in the first row, second column. Where is the intersection? That is the element 1. Do you get it? Now, if I ask you to tell me the element, identify the element A12. A12 means you are to identify the element found in the first row, second column. And that element is what? 2. Okay. If I ask you to tell me the element A22, can somebody tell us A22? Which element is that? A22. Yes. Tell us.
4.
4. That's correct. So if you see such simple questions, you should be able to answer. So that is what we mean by that. So now we can define a matrix where we say it is a rectangular array of numbers, variables, or functions. So if I ask you to define functions, a matrix you should be able to define. Then you should be able to name the members of the matrix, and we say they are called the entry or the elements of the matrix. If I ask you to determine the size of the matrix, you should be able to determine using what? The number of rows of the matrix by the number of columns of the matrix. Then if I ask you to denote or name a matrix, you know that it is capital letters that we use to name matrices. Thank God it's Saturday. So we have talked about all this. Now, these are more examples on the dimension or size or what? Order of a matrix. Look at a matrix which has only one member. It has only one element. It has only one entry. And so if I ask you to tell me the size, I give you such a question, I say, what is the size of this matrix? You should be able to count the number of rows and the number of columns. How many rows are here? Only one row. How many columns? Only one column. So you say you have a 1 by 1 matrix. So that's the size, that's the order, that's the dimension of the matrix. You see the second one, it has two elements all in only one row. By how many columns? 1, 2 columns. So it has the size is 1 by 2 matrix. So this matrix is a 1 by 2 matrix. That's the size, that's the order, that's the dimension. So you look at the other example, it has only one column. By how many rows? 1, 2 rows. So 2 rows, 1 column. So it is a 2 by 1 matrix. Look at the third example or the fourth example. It has 2 rows and 2 columns. So this is a 2 by 2 matrix. Look at the last example here. It has 2 rows, 1, 2, 3 columns. So it is a 2 by 3 matrix. So you should know what the size, the order, and the dimension of a matrix are. Thank God it's Saturday. Then we come to the types of matrices. We have various types of matrices. Now, if you see the first example or the first type of matrix is what we call the row matrix. Row matrix. The row matrix. What is a row matrix? It is a matrix which has only one row. So if you see a matrix which has only one row, the number of columns can be uncountable. We don't care about that. All we care about is that we see that there is only one row, and that makes it what? A row matrix. So that is the type of matrix called row matrix. So these are our examples. You can see that they all have only one row, but the number of columns are different. But only one row can be found. So that is a row matrix. If you have any question, please draw my attention, ask your question freely, then we will answer you freely in a nice way. Then the next type of matrix is what we call the column matrix, which is directly opposite to the row matrix. Okay, so in this case, you see only one column. The number of rows can be uncountable. We don't care about that. So all we want to see is that there's only one column, and so you call it a column matrix. So that is the type of matrix called column matrix. That's only one single column. So these are examples of that. You could see they are all only one columns. Then we have another type of matrix called the zero matrix. Zero matrix. What is it? It is a matrix whose entries or whose elements are all zeros. You don't see any number apart from zero. As you can see, these are all examples. Okay, so these are, so if you see such a thing, I give you something like this, I ask you to name the type of matrix it is, you should be able to name. Then we come to another type of matrix called the rectangular matrix. Now, what is a rectangular matrix? It is a matrix whose number of rows and number of columns are not the same. They are different. So anytime you have a matrix whose number of rows and number of columns are different, you say it is a rectangular matrix. So that is the type of matrix called rectangular matrix. So these are all examples. You could see that the number of rows is different from the number of columns. You could look at this one too. The number of rows is also different from the number of columns. So that is what a rectangular matrix. The opposite of this is the square matrix, where you have the number, both the number of rows and the number of columns being equal. They are the same. So where the number of rows and number of columns are the same, you say it is a square matrix. So that is the type of matrix called square matrix. So these are examples. You could see that the number of rows and number of columns are the same. So if you see such a question, as we will give you such a matrix, ask you to name the type of matrix it is, you should be able to identify that. Then we have another type of matrix called the leading or main diagonal matrix. The leading or main diagonal matrix. Now, if you look at this example here, how many diagonals do you see here in this matrix? How many diagonals? Tell me. Hello?
2, sir.
2 diagonals. You have the one from the top left corner all the way to the bottom right corner. Then you have another one from the top right corner all the way to the bottom left corner. But when we refer to the leading or main diagonal matrix, we are referring to the diagonal which begins from the top left corner all the way to the bottom right corner, as you can see highlighted in blue. Okay, please, you must identify this. You should be able to identify this, because if you are not able to identify this, we are going to do a lot of things which needs the identification of the leading diagonal or main diagonal entry. If you don't know it, there are certain questions you can answer. So please take it from now. So this diagonal is what we call the main or leading diagonal. Then we also have what we call the trace of a matrix. Trace of a matrix. What is it? It is the sum of all the elements in the leading or main diagonal of a square matrix. It is the sum of all the elements or entries in the main or leading diagonal of a square matrix. So if you take this matrix, this is the main or leading diagonal. So you sum, when you sum all the elements, A11 plus A22 plus A33 all the way to AMN, then the result is what we call the trace, and this is how we identify it. So I'll give you a matrix like this, and I ask you to find TR of A. That is the trace of A. So I ask you to find the trace of A. This is what you have to do. I hope that is clear. Let's look at some examples. You have to find the trace of the following matrices. So look at this. The first matrix is matrix A, which is 1, 3, 3, 4. You have to find the trace of this. What do? You identify the leading or main diagonal. That's why I told you that if you are unable to identify the main or leading diagonal, then there are certain questions you cannot answer. It will be difficult for you to answer, because for you to be able to answer such questions, you should be able to identify the main or leading diagonal matrix. So if you take the first one, the trace of A, this is the main diagonal or the leading diagonal. So the trace of A will be 1 plus 4, and that gives you 5. That's what you see here. The trace of K, so the leading diagonal is this. So the trace of K is 2 plus negative 1, and that gives you what? 2 minus 1, and that gives you positive 1. If you take the last one, P, this is the leading diagonal. So the trace of P will be 4 plus 1 plus negative 3. And that will give you what? Positive 2. Please, any question on this? Any question? I don't see anyone hand up. So silence means consent. Thank God it's Saturday. Let's continue. Then we come to the other type of what? Matrix called the triangular matrix. The triangular matrix. Now, what is a triangular matrix? It is a square matrix where all entries above or below the main diagonal are zeros. It is a square matrix where all entries above or below the main diagonal or the leading diagonal are zeros. And we have two types of triangular matrices. We have the upper triangular matrix and the lower triangular matrix. So as you can see, once again, if you are not able to identify the leading or main diagonal entry, then you are out. You can answer such a question. So if you look at this, this is the main or leading diagonal. And so you could see that all the elements below it are zeros. And so you call it, when that happens, you say this is an upper triangular matrix. Then where all the elements above the leading diagonal are zeros, you say it is a lower triangular matrix. Look at some more examples here. These are all upper triangular matrices. You see where the zero is. This is the main diagonal, and the element below it is zero. So that is upper triangular matrix. Look at this one too. This is the main diagonal. And look at all the elements below, zeros. So that is an upper triangular matrix. Now look at this one as well. All this is the main diagonal. All the elements below are zeros. So that is an upper triangular matrix. Let's look at lower triangular matrices. These are all examples of lower triangular matrices. You see where the zeros are. You see the leading diagonal. You see them. So these are all lower triangular matrices. So when you see questions of this nature, you shouldn't be scared. You should be able to identify and answer nicely. Thank God it's Saturday. Any question? Then no questionnaire. Thank God it's Saturday. We continue to the next type of matrix, which is a diagonal matrix. The diagonal matrix. Now I may ask, we've seen the leading or main diagonal matrix. What else is the diagonal matrix? I believe some of you have seen the difference. Tell me what the difference you've seen concerning the diagonal matrix and the main or leading diagonal. What is the difference? Tell me. Or tell us. Yes, go ahead.
Okay. The combination of the upper triangular and the lower triangular.
That is fine, but I want a clear thing. Yes, let everybody understand. There's something you can see straightforward. Let everybody know that. Have you seen it?
The zeros in the question.
The zeros. What have the zeros done?
So that is when the values above and below the main diagonals are zero.
That's all. So all the entries or elements which are above and below the main diagonal are zeros. So everything is zero apart from elements in the main diagonal. So that gives you what? A diagonal matrix. Take note. Now the next one you are going to see is also similar to this. I pray you'll be able to see the distinction there. Let's see that one as well. We call it the identity or unit matrix. Identity or unit matrix. Let's see. I'll leave the reading for you to go and do. But let's look at the examples. Now look at the examples. What is the difference between this, the diagonal matrix, and the leading diagonal matrix. What have you seen? Tell us.
The
Go ahead.
the difference is that the leading diagonals, the numbers are the elements, they are all one.
They are all unity. That's
yes,
right. That's right. Whereas the other ones can have different numbers. This one, the only numbers in the leading diagonal are one. You will not get any other number apart from one. That's it. So you should be able to identify them. Now take note. When it comes to the identity metrics, they also follow the size of the matrix. So if you look at the first identity or unit matrix, the size of the matrix is 2 by 2. So if you have a 2 by 2 matrix, this is what the unit or identity matrix, 1, 3, 3, 1. And if you have a 3 by 3, you see that it's also, so it follows the size or the dimension or the order of the matrix. Very, very important. So if you have 4 by 4 matrix, can you write out the unit matrix? You realize that 4 by 4 have what? 1, 3, 3, 3, 3, 1, 3, 3, 3, 3, 1, 3, and the last one will be 3, 3, 3, 1. But now when I mention 3, I know the non-Ghanaians know what I mean by 3, because the first day I explained that. I believe Mr. Ture remembers.
Yes, I do, Doc.
Good. So that is that. So if I ask you to write the unit or identity matrix for 5 by 5 matrix, you should be able to write. Go and practice that, because one day I'll ask you to write out the unit or identity matrix for a 10 by 10 matrix. So go and start practicing. If there is no question, we move on. Yes, madam.
Please, I want to ask, so are you saying that the identity matrix is a square matrix with a leading diagonal of 1?
Yes. All the elements in the leading diagonal are 1, 1, 1 unity. You will not get anything apart from the unity. That's all. So is there any other question? All right. And we continue. So the readings, you can go and read them. If you don't read, it's your own problem, because I'll pick questions from them. I told you I'll not read. So read them. So, oh, sorry. Now I'm on what? Transpose of matrices. How do we transpose a matrix? So I'll give you a matrix and I ask you to transpose it. And this is how we denote the transpose of what? The matrix A. So you have the matrix A, and when you see A raised to the power T, the T can be a small letter or capital letter. Yeah, they mean the same thing. So this refers to what? The transpose of the matrix A. Okay, what does it mean? If I give you a matrix A and I ask you to find A transpose, all that I'm asking you to do is to turn each row into a column. So you take them row by row. You take the first row, you turn it into a column. You take the second row, you turn it into a column, like that. So that is how it works. Let's see some examples. So look at this. You see the matrix A, 2, 6, 3, 1, 3, 4. Now I ask you to find A transpose. What happened? You see, you take the first row and you turn it into a column. Have you seen it? Then you take the second row, you turn it into a column. So this is what we mean by the transpose of A. Any question on that, please? Any question? No question. Thank God it's Saturday, so you've understood it. Nice one. You see another one. This is the matrix A, and this is the transpose of it. So you just turn the row into a column. So that is all that we mean by transposition. You take each row, you turn it into a column like this. So this is the transpose of this. The row has now become a column. The same thing you see here. These are more examples. So if you have understood it, when you take your slides, you practice them, and we shall all be fine. So you see A transpose. You see it. So the first row becomes the first column. The second row changes into the second column. You see this. The first row becomes the first column. The second row becomes the second column, like that. So this is what we mean by transposition. Please, any question on that? You don't have any question? We move on. So these are more examples. You can try your hands, practice, and you have the solutions also here. So when you practice, you come and check the solutions and you mark yourself. That's all. It's as simple as that. So that is what we mean by transposition. Then we also have what we call the symmetric matrix. When do we say a matrix is symmetric? For you to be able to identify a symmetric matrix, you must be able to give the transpose of that matrix. Okay, so if I ask you to determine the symmetry or whether a given matrix is symmetric or not, all that I'm asking you to do is to take the transpose or find the transpose of that matrix. And when you finish taking the transpose of the matrix, compare the answer to the original matrix. So assuming I give you the matrix A, I ask you to find the transpose of the matrix A. If at the end of finding the transpose of the matrix A, you realize that the answer you've gotten to the transpose is the same as the original matrix A, then you say the original matrix A is symmetric. I hope I've made myself clear. So when you find the transpose of a given matrix and the result you get from the transpose, you realize that it is exactly equal to or exactly the same as the original matrix that you transposed, then you call the original matrix symmetric. That is what we mean by symmetry of matrices. Any questions here, ladies and gentlemen? Ladies and gentlemen, if there's no question, look at some examples here. Look at this. The matrix A, that is what we have here. Now you take the transpose of the matrix A, look at the result. When you turn this into column, you turn this into column. Now you compare the result to the original thing. You see that they are the same. So you say the matrix A, that's the original matrix A, is symmetric. That is all. Look at the second example. Look at the transpose. Compare the transpose to the original matrix. What do you see? They are equal. They are the same. And so you call the original matrix B symmetric. That is all. Any question? Miss Johnson? No question? Okay. Then we move on. And you see the third example. Look at the transpose. This is the original. Look at the transpose. Are they different? No, the same thing. So you take the first row, it becomes the first column. You take the second row, it becomes the second column. Take the third row, it becomes the third column. Take the last row, it becomes the last column. And you compare, you see that there's no change, no difference. They are the same. And so you say the matrix C is what? Symmetric. So we've seen that all these examples are what? Symmetric matrices. So this is what we refer to as what? Symmetric matrices. So please take note. These are questions I can easily put in the objectives for you to identify. So if you don't understand, let us explain to you to understand before that day comes. Else, and the voila. So that is that. Then we come to matrix operations. Matrix operations. What do we mean by matrix operations? What we mean by matrix operations is this. Anytime you say operations, you are looking at what? Addition, subtraction, and what? Multiplication. Addition, subtraction, and multiplication. That is what we mean by matrix operations. So let's start with what? Equality of matrices. Equality of matrices. Two matrices we say are said to be what? Equal. If and only if they have the same order or size or dimension, and also the same entries. So their size is the same, their dimension is the same, or their order is the same. Then their entries, their corresponding entries. What do I mean by corresponding entries? Corresponding entries are entries which are found in the same positions in both matrices. So when you look at this matrix, if you have 2 in this corner and the same 2 in this corner, if you have 3 in this middle and you have the same 3 at the middle, then if you have A here, it should also be A. So if A and B here are the same, then it means this A, this variable A, must be equal to what? 9. Then you can say they are the same. If you check B here, if A is equal to B, then this B, this variable B here must be equal to -3 because they are found at the same position. Then 6 equals 6, 1 equals 1. So this is how you identify equal. So you can easily say that the two matrices A and B are equal. But if you check what? A and C and B and C, you see that they are not the same. Even their sizes are different. This is 3 by 3. This is 2 by 3. This is also 2 by 3. I don't know if you are following. Are you following all that I am doing here? Do you follow?
I follow you, sir.
Yes, sir.
Yes.
Doc, please take this.
Yes. I should take it from where?
Equality of the matrix.
So you want me to rewind? Let me rewind for you.
Yes, please.
I rewind. So I said that for two matrices, let's consider this A and B. This matrix A, this matrix B. Now let me even leave here. Let me go to another point so that you get exactly what I mean before if I'll come back here. Good. Look at this illustration here. Look at the matrix A. Look at the matrix B. Okay. You see that you have 5 in row 1, column 1. Come here, the same 5 in row 1, column 1. You have 2 in row 1, column 2. Come here, the same 2 in row 1, column 2. You have 8 in row 2, column 1. Come here, the same 8 in row 2, column 1. Here you have 4 in row 2, column 2. Come here, the same 4 in row 2, column 2. Now look at the two, A and B. Are they equal? Yes, they are the same. They are equal. So you say A is equal to B. That's what I was saying. Are you okay with that now?
Yes, please. Thank you.
Welcome, madam. But you see, it is my father I didn't see. So I didn't know my dad because I was less than 3 years when my dad died. So I didn't see him. I only grew up to see his picture. So I know him through his picture. However, my mom brought me up in a very, I don't think my mom brought me up to be stupid. No. My mom didn't bring me up to be foolish. No. Now, ladies and gentlemen, look at this. Do you think I'll be that stupid to give you A to be this and give you B to be this? Then I ask, tell me whether A is equal to B. Is it a good question to ask? Is it a good question? If I give you this and give you this, I ask you to tell me whether A is equal to B. Is it a good question?
It's a simple question.
So is it a good question to ask?
Kind of.
Yeah. What did you say?
Yeah. What did you say? Kind of. Kind of.
But how will I give you this?
But how will I give you this?
I can't give you this. It will be so stupid on my part to give you A when it is clear, you can see this clearly that they are the same, they are equal. Then I give you this to tell me whether they are equal or not. I can't. That would make me look stupid. But this is the way I can give you this. Okay. So if I give you 2, 3, A, B says 1, I give you B to be this. Then I ask you to find A and B. Find the values of A and B. If A is equal to B, then that becomes a sensible question to ask. Then it means I am testing your knowledge on what? Equality of what? Matrices, where you know that elements in corresponding positions are equal. So you now say, oh, okay, if that is the case, then 2 must be equal to 2, 3 must be equal to 3, and so A must be equal to 9, and B must be equal to what? -3. So this is the only sensible means by which I can ask questions of this nature. I hope that is clear. Let me go and show you more sensible ways by which I can ask. Even here, I can simply put maybe this may be 5 and I'll put 2x here. I'll attach x to the 2. Then if I ask you to find the value of x, if A is equal to B, then you should be able to see that, oh, I'm testing your knowledge on equality of matrices. So if they are equal, then 5 must be equal to 5. And so 2x must be equal to 2. Now, if 2x equal to 2, and I need the value of x, what do? I divide through by 2. And so 2 cancels, and x is equal to 1. So these are the sensible means by which I can test your knowledge on equality of matrices. Please, so take note. Very, very important. There are more examples here. Look at this. Well, if I give you this question, I give you A to be this, I give you B to be this. Then I ask you to find the value of what? X, Y, Z, and W if A is equal to B. So nice way. So this is to test the knowledge of what? Equality of matrices. So X is in the same position as what? 2. And so X is equal to 2, as you can see. Y plus 1 are in the same position as 7. So it means Y plus 1 is equal to what? 7. Then you make Y the subject. So Y is equal to 7 minus 1. So Y is 6. Please, do you understand what I am doing?
Yes, sir.
Yes, sir.
Nice one. Then 2Z are in the same position as 4. And so it means 2Z is equal to 4. And so we make Z the subject. So we divide through by 2. So Z will be equal to 4 over 2. And that will give us what? 2. And then 5W is in the same position as what? 2. And so 5W is equal to 2. Then we make W the subject. You divide 2 by what? 5. And so W will be equal to what? 2/5. So these are the sensible means by which questions on equality of matrices can be put. But I cannot just give you the raw matrices like that, where you can clearly see that they are equal. Then I ask you, are they equal? That is a useless question. I will never do. So take note. Then these are more examples. So you can go and practice on all this. I give you the matrix A as this, the matrix B as this. I say, if A is equal to B, find the values of X and Y. So by now, you know what to do. So you can go and follow. Thank God it's Saturday. So these are our examples. You can go and try your hands on. Then we come to addition and subtraction of matrices. Addition and subtraction of matrices. Addition, subtraction of matrices. Okay, addition and subtraction of matrices. Now, if you've understood how we dealt with equality of matrices, referring to entries in the same position being equal, then the same thing applies to what? Addition and subtractions. You can only add or subtract entries or elements at the same positions. That is, you can only add or subtract corresponding entries or corresponding elements. So elements which are found at the same position can be added to each other. Okay, so that's what we mean. But take note that matrices of different orders or sizes cannot be added or subtracted. So if they don't have, before you can add or subtract, they should have the same size, the same dimension, or the same order. Then you can add or subtract. And they have a name. Anytime two matrices which can be added or subtracted to each other from each other are said to be what? Conformable for addition or subtraction. Okay, so anytime you have two matrices or three matrices which can be added or subtracted from each other, then you say those matrices are conformable. 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 So that is what we mean by conformable matrices. And take note that addition of matrices is commutative. So matrix addition is commutative. Why do we say it is commutative? If you add matrix A to matrix B, the same answer you get for what? The addition of matrix B to matrix A. Okay, so we'll see some examples and then you can confirm. However, subtraction of matrices will never be what? Commutative. It doesn't work. So take note. So these are simple questions. I can just put there for you to answer. So take note. Okay. Now, the operations, addition and subtraction, are carried on corresponding entries of the matrices involved, as I've already said. And these are some examples. If I give you a matrix A to be A, B, C, D, I give you a matrix B to be E, F, G, H, I ask you to find A plus B. So your duty is to add corresponding elements to each other. So A is found in this corner, and it is the same corner that E finds itself. So you add A to E. So that is what you see. So you can only add B to F, as you see, because they are in the same position. You can add C to what? G, because they are in the same position. And you can also add T to H, because they are in the same position. So take note of that. If it comes to subtraction, it is the same thing. You can only subtract E from A or A from E, because they are in the same position. So that's what you see here. Please, any question on this? Don't have any question? Thank God it's Saturday. Look at more examples. So I give you a matrix A, I give you the matrix B, I give you the matrix C, and I ask you all these questions. So by now you should be able to go and answer them. Okay. Now what is your conclusion? What conclusion can you draw from the operations in this? You should be able to give us. So that is what we mean. So I've solved them here. So you see A plus B. This is A, this is B. So 1 and -5 are in the same position. So you can add 1 to -5 and get your result. 4 and 7, the same position. 6, -6, -3, same position. 3 and 9, same position. So you can add them. And this is your result. I thank God it is Saturday. So we can continue. So these are our examples you can go and practice for yourself. Okay. So from all these examples, you can see, and those are the conclusions I was asking you to draw. You can see that A plus B is the same as B plus A. So it means addition of matrices is commutative. Then you realize also that A minus C was not equal to what? C minus A. So it tells you that subtraction of matrices is not commutative. Then we also have A plus B plus C being equal to A plus B plus C. And we say addition is associative. Remember all these things: associativity or property of associativity, you have commutativity, you have even distribution, all those properties. If you have forgotten, go and revise. So I can ask you all these simple things. And if you revise well, you will not find yourself wanting at all, and we shall be fine. Thank God it's Saturday. So I think we'll go for our break here and come back and continue with what? Yeah, okay, let me finish with the application on addition before we go for break. Okay, so this is an application question on addition. Okay, look at this. You have to consider an automobile dealer who sells two brands, Peugeot and Mercedes. Each is available in two colors, red and blue. Suppose the dealer's sales for January and February are represented respectively by the sales matrices. As you can see, so these are the sales matrices. January sales, okay, Peugeot, Mercedes, is it red and blue? Or the Kaya, red and blue. So the rows are what? Red and blue. So row 1 is red, row 2 is blue. Column 1 is Peugeot, column 2 is Mercedes-Benz. So for January, you can talk about, so it means in January, one red colored Peugeot was sold, and you're off. Okay. One red colored Peugeot was sold, and two red colored Mercedes were sold. The same January, three red colored Peugeots were sold, and then three blue colored Peugeots were sold, and five blue colored Mercedes were sold. In February, three red colored Peugeots were sold, and one red colored Mercedes was sold. Four blue colored Peugeot was sold, and two blue colored Mercedes were sold. You have to find what? The total sales. Now the total sales for each brand and color for the 2 months, J and F, that's January and February, is obtained by adding the corresponding entry. So it's the same addition that you are doing. Okay, so this is the first one, this is the second one. So J plus F. So 1 plus 3, 4. 2 plus 1, 3. 3 plus 4, 7. And 5 plus 2, 7. So that is what you have. So if you see such questions, you should be able to answer it in a nice way. So with this, if there's no question, we can go for our break and come back. How many minutes are we going for break?
30 minutes.
Okay, so it is 9:34. So we come back by, when are we supposed to close? 12:30, right? Or 12 o'clock? I will close before then, so don't worry. When you come back, we may spend maybe 30 minutes or so, and then we'll close. So go for your break, refresh your memory, and come back. Then we look at scalar multiplication and multiplication of matrices, and then we close.
So, Doc.
So see you. Yes, sir.
Yes, when are you going to share the slides for this one?
Oh, I'll share it. Maybe, okay, whilst you're on break, let me share it.
Yes, please.
Yes, but I have also put it on your LMS. All my materials are on the LMS now, platform now.
Okay, all right, thank you.
Whilst you're on break, I'll share this one as well on the WhatsApp platform.
Okay.
Somebody should send hi in the group WhatsApp page so that I see it easily and share this there. Thank you.
Okay,
Another
so
question before we go? No, that's the next session. Thank you. gives you this, and then K multiplies D, and that gives you KD, as you can see. So that is what it means. Now the K can be any number. It can be a whole number, it can be a fraction, it can be positive, it can be negative, any number at all, just one number. That is what you refer to as the scalar. Any question on that? Okay, so let's look at some examples. If you look at this example, if I give you this matrix A to be 1, 2, 3, 1, 2, 4, negative 2, and I give you your scalar K to be 10. So I ask you to find K times A. That means 10 times A. So you multiply 10 by the matrix A. And it means that 10 will multiply all the elements in the matrix A. So that is what you see here. And so 10 times 1 gives you 10. 10 times 2 gives you 20. 10 times 4 gives you 40. And 10 times negative 2 gives us negative 20. So that is what it means by what? Scalar multiplication of matrix. Have I made myself clear? Is there any question to ask for any explanation? I don't see any hand up. Okay, so that's fine. So these are more examples on scalar. If you look at this, given the matrix P to be 5, 6, 8, 4, the matrix Q to be 12, 7, 4, and 9, you are to find 3P plus 5Q. 3P plus 5Q. What does it mean? Let me see. I think I have some messages in the chat room. Okay. Still, my voice is down. Let me check. Maybe I have to increase the volume on the PC. Let me check first where the volume is. No, I have high volume here, so okay. So let's continue and see what will happen. So we are looking at what? The matrix P, which has been given, and the matrix Q, which has also been given. Then we are to find 3P, 3 times the matrix P, plus 5 times the matrix Q. So the scalar here is 3 for P, and then 5 for what? The matrix Q. So you have to multiply the elements, each of the elements in the matrix P by 3. Then you also multiply each of the elements in the matrix Q by 5. Then you sum the results. So that's what you see here. 3P, that's what you multiply. So 3 multiplying the elements in the matrix P. Then 5 times Q. So 5 will also multiply the elements in the matrix Q. So each of them. So you have 3 times 5, that gives us 15. 3 times 6, that gives us 18. 3 times 8, that gives us 24. 3 times 4, that gives us 12. And we come to Q, 5 times Q. So 5 times 12 gives us 60. 5 times 7 gives us 35. 5 times 4 gives us 20. And 5 times 9 gives us 45. So we have finished with the scalar multiplication. Now we are back to the addition. And you know that you add elements found in the same positions. So 15 is added to 60 because they are found in the same position. That gives us 75. 18 is added to 35 because they are found in the same position. So that gives us 53. 24 is added to 20 because they are found in the same position, and that gives us 44. Then 12 is also added to 45 because they are found in the same position, and that gives us 57. And this is what we mean by operations on multiplication. Ladies and gentlemen, any question on that? Do we all understand this? Hello?
Yes,
Yes,
please.
Yes,
yes,
sir.
bro.
Yes, sir.
It's
All
clear.
right. Then sorry. The network fucked me up. Can you hear me?
Yes,
Yes,
sir.
sir.
Yes, we can.
The network fucked me up, so I'm back. I believe you can see the screen now.
Yes, sir.
All right. So we want to continue with the multiplication. And we want to multiply two matrices. If A is an M by N matrix and B is an N by P matrix, the product AB will give us C. Okay, the product AB, which gives us C, is of dimension M by P. For this product to exist, the number of columns in A, that is N, must equal the number of rows in B, that is N. It follows that if this. Now, what am I saying here? For you to be able to multiply two different matrices A and B and get the result, if the first one is M by N, that's the size, and the second one is N by P, when you finish, the resulting product of the matrices should be what? M by P. The N and the N here cancels out. So if you multiply M by N matrix by N by P matrix, the result should be of size M by P. So take note. You understand as we move on. So for instance, let me skip this one. This may not help you so much, but later you can go and look at it. Let's look at this. Let's start by multiplying rows by columns, a row by a column. Now, if you multiply a row by a column, the result will give you just a matrix with only one entry. To give you a matrix with only one entry. So if this is matrix A and this is matrix B, and we are multiplying A by B. So that is what you see here. What do? We have learned about the transposition of matrices. So the first thing you do is to transpose what? The first matrix, the row. You transpose the row. When you transpose it, it becomes the column. So you see the A1 matching B1, A2 matching B2, the dashes will match the dashes, and AN will match BN when you transpose it. So it will just lift up. It will lift itself up like this. So you see it standing. Okay, you see it standing with A at the same level as B1, A2 at the same level as B2. The dashes will be at the same level, and AN will also be at the same level as BN. And then you multiply them in that matching order. So A1 will multiply B1, A2 multiply B2, the dashes will multiply the dashes, and what? AN will multiply BN. So those are the results you see here. This is how we do the multiplications. Okay, so before you multiply, you take the row, transpose it, or you lift it up. When you lift this up, you see the A1 matching B1, A2 matching B2, the dashes will match the dashes, and AN will match BN. And you multiply them in that matching order. So A1 times B1, that gives you this result. A2 times B2, that gives you this result. Dashes times dashes, that gives you this result. AN times BN, that gives you this result. And you sum them. So it becomes A1 times B1 plus B plus A2 times B2 plus dash times dash plus AN times B2. And that is, sorry, times B1, sorry, BN. So that is what gives you this. Let's use figures and then you see what we are talking about. Look at this. I think this one is an error here. It should be capital A, not small a. So sorry for that. This should also be capital B, not small b. So you can correct it later. Now, but the key thing is we are multiplying this row matrix by this column matrix. Okay, so what do? So AB is what you see here, the A times B. Now, before you multiply, what did we say? You have to transpose the first one, the A, transpose it. And if you transpose it, it means it is lying down and you are lifting it up. The row changes to become a column. So when it stands up, you see 4 matching -4, -10 will match +3, and +3 will match +8. So you multiply them in that matching order, and then you add them. Okay, so we are going to get 4 times -4, and that will give, that is what you see here, plus -10 times 3, and that is what you see here, plus +3 times 8, and that is what you see here. Now, if you multiply -4 times, +4 times -4 gives you -16, plus -10 times 3, that gives you -80. Good. Plus 3 times 8. 3 times 8 is 24. Now, you have -16 plus -30. What do you get?
46.
That gives
-46.
you -46. Yes. Now, -46 plus 24. What do you get? So you owe 46 cedis. You owe
22.
46 cedis. You go and pay 24 cedis, so you still owe 22. So that is the -22 cedis you have here. Okay. Are we okay with the multiplication? Is there any question on that? Can we all multiply now? You take the transpose of the first one, the row, you change the rows into columns, then you use them to multiply. If we understand this, then we can go ahead and do the full multiplication of a full matrix. Any question on this? Silence means consent, right? Thank God it's Saturday. Then we are moving on. But there are still more examples here. Okay, you still see another one. This is the row. multiplying. This is a column. Now look at this. I can easily use this to trick you. Okay, if I give you this as a row and I put the transposition sign on it, it means this is not a row, but it is a column. So you have to transpose it. Now, if you transpose it, you see that you have the column. That is the column you see. So you just lift it up. It is lying down, and then you lift it up. Now it is standing. Then, before you multiply A by B, you have to let A also stand. Now, if you let it stand, that's what you mean by the transposition. You change the row into what? Column. So you transpose this, and you see 1 matching 2, 4 matching 1, -3 matching 4, and +10 matching -2. So you multiply them in that matching order. So you have 1 times 2, that's what you see here, plus 4 times 1, that's what you see here. Dot in mathematics means multiplication. So the dot you are seeing there means times. Then plus -3 times 4, that's what you see here. Okay, plus 10 times -2, and that's what you see here. So if you multiply 1 by 2, you get 2, +2. 4 times 1, you get +4. So that gives you +6. Then -3 times 4 gives you -12. 10 times -2 gives you -20. -12 plus -20 will give you what? -32. Now, -32 plus +6. You owe 32 cedis, you go and pay 6 cedis. You still owe negative, you owe 26 cedis. So that is the result. So this is how we multiply matrices. We have multiplied the row by the column, and it is the same. I decided to start like that because when you go to the full matrices, that is how you are going to take them. You take them row by row and multiply and put the answers there. So if you understand how we have done this, then when we are going for the full matrix, there shouldn't be a challenge. So if we are ready, let's move. So this is a similar one. This is a similar application one. So let me finish with the application on the row by column, then we continue. So suppose the prices in Ghana cedis per unit for a product A, B, and C are represented by the price matrix below. So this is the price matrix, A, B, C. And so we name that price matrix as matrix P. Now each column is labeled A, B, and C. Now, the quantities purchased are given by the quantity matrix, as you see, the quantity matrix Q, where you have 7 units of matrix of product A purchased, 5 units of product B purchased, and then 11 units of product C purchased. Now the question is, you are to compute, okay? You are to compute what? The total expenditure on the products. You have to compute the total expenditure on the products. So it means you have to multiply the row by the column. That is all. So if you multiply, it means you have to transpose the first one, lift it up, that is 10, to match the second one. So 2 will match 7, 3 will match 5, and 4 will match 11. So you multiply and sum them in that order. So 2 times 7, that's what you see. 3 times 5, that's what you see. And 4 times 11, that's what you see. So 2 times 7 will give you 14. 3 times 5 will give you 15. 4 times 11 will give you 44. When you sum them, you are getting what? A matrix with only one entry, which is 73. And so the total expenditure, what does the 73 mean? What does that figure mean? it means the total expenditure on products A, B, and C is 73 Ghana cedis. That's all. You must be able to conclude if you have such a question. So take note. Ladies and gentlemen, if you have any question, if you don't have any question, are we ready to zoom in to the full
Hello,
action?
sir.
Yes, sir.
Sir, please, the 1 times 1, what does it stand for?
So are you now joining us? Were you with us from the beginning? That's the size. It's not times 1 by 1. Look at
Okay.
the matrix you found here. It's a matrix. Now, how many rows, how many columns? That's only one row and only one column. That is 1 by 1. So the size of this final answer is what? The 1 by 1 matrix.
Okay.
That is
Okay.
what it is.
Thank you, sir.
Any other thing? Are we ready to move? Okay, so let's move. Now we want to multiply the full matrix. And I mentioned that the multiplication or product of two matrices is possible if and only if the number of columns of the first matrix is the same as the number of rows of the second matrix. I said this earlier. Before you can multiply two matrices, you have to make sure that the number of columns in the first matrix is the same as the number of rows in the second matrix. If the number of columns in the first matrix is not the same as the number of rows in the second matrix, there is no way you can multiply the two matrices. So take note. And for this, I've already mentioned this multiplication and the results that you get in terms of the size of the final matrix. But take note that the product of two matrices is not commutative. Matrix multiplication is not commutative. So if you multiply A times B, the answer you get can never be the same as the multiplication of B times A. So they are not the same. That is why if you are given two matrices A and B and you are asked to multiply, when you are bringing the matrices, you should follow in that order. If the question gives you A first, when you are copying the matrix, bring A first before you bring B. If you make a mistake and you go and bring B before A, the answer you get will be wrong. So be careful. And the same way, if the question says find B times A, find B times A, the question mentions B first, B times A. You don't go and bring, when you are copying the matrices, you don't go and bring A first. If you do that, you get it wrong. You follow the order in which the question came and bring the matrices in that order. I hope that is clear. Thank God.
Yes, sir.
It's Saturday. Good. So this is the formula. I give you a matrix A, B, C, D, and the next one E, F, G, H, and you have to multiply A, B. So you see, in copying, in bringing the matrices, I went in that order, A first, so A comes first, then followed by B. Then, just as the way we multiplied the rows and column, you take them row by row. So you take the first row, take the transpose of it. So you lift it up to stand. So when you do that, you see A matching E and B matching G. So you multiply A times E plus B times G. What you are using to multiply is the first row. So the answers you get should be in the first row. Now, if you multiply A by E and B by G and you add them, where do you put the answer? You have used the first row to multiply the first column. So the answer must be in the first row, first column. So that is where you see the position here. Then when you finish, you use the same A, B to multiply F and H. And so once again, you are taking the first row to multiply the second column. So the answer will be put in the first row, second column, as you see. If there were to be a third column, you still use it, AB, to multiply that third column and put the answer in the first row, third column in that order. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Then when you finish with the first row, good. So after you finish using the first row to multiply every column there, you come for what? The next row and do the same thing. So you pick the next row now, CD, transpose it. So you lift it up, let it stand. When it stands, C will match E, D will match G. So you multiply in that order. So C times E plus D times G. This time you pick from the second row and use it to multiply the first column. So the answer you got will also be in the second row, first column. So you see the position. When you finish, you use the same CD to multiply the second column as well. So you have what? C times F plus D times H. Now you are using the second row to multiply the second column. So the answer will be in the second row, second column as you see. So that is what you see here. If it is 3 by 3, the same thing. Okay. Now if you want to find BA, I've asked you to go and find BA. It means you are bringing the B matrix first before the A, and then you do the same multiplication. So you can go and practice that. Now this is 3 by 3, the same thing. So you take the first row, AB, so you bring the A first, followed by the B. You do what? You take the first row, so you take them row by row. You take the first row, transpose it, so lift it up, let it stand. So when you let it stand, you see A matching J, B matching M, and C matching P in that order. So you multiply in that order, just as we did for the 2 by 2. You've picked from the first row and use it to multiply the first column. So the answer will be in the first row, first column, as you can see. Then when you finish, you use the same ABC to multiply K and Q, the second column. And you keep the answer in the second column, first row, second column. When you finish, you use the same ABC to multiply the third column, LOR. Now you are using the first row to multiply the third column. So the answer will still be in the first row, but third column, as you see. Now you are done with the first row. You come and take the second row and do the same thing and put the answers there like that. When you finish, you go for the third row, do the same thing and put the answers there like that. So that is what you see. Okay, I can see some message there. Let me read it and see what news is there. What is the news? News? Or sister, can you please speak a bit louder? Please, are you, or is it from, it could be from his end.
Let
No,
them
it's,
increase
it's
their
from his
volume.
end,
It's
though.
okay.
Yeah, it's very okay here.
It's
So
okay.
it is. So please check your connection from your end, please. It might be your internet there. Thank you. So let's continue if there's no question. So let's look at some examples. Now look at this example. You have to compute AB, where A is this and B is this. Okay, so now I'm giving you figures to compute. So you take them. So this is your AB. I think this thing will help. The way I splitted it up, maybe it will help somebody. So you multiply, I said multiply A times B1. Right? Multiply A times B1. What do I mean by that? So you take the first, no, this one can confuse you. So let's go. But what you have to do is this, AB. So you bring A, you bring B. And you take the first row, which is 2, 3, transpose it. So it will stand up. Who is this? Who is this? Please, sorry. This is about your class in Timmy Poma. This is about your class in Timmy Poma. Sorry for that. Let's continue. So I was saying that